Okay. Right, so the session is being recorded. All right, yeah, let's look at questions like these. We want to look at questions like this, right? Okay. Now, if you have a situation like this, right, let me just write it. Let me just write it on a clean. Okay. All right, so we need to be as fast, so we'll be as fast as possible. Please, everyone, those who, can you all mute your videos so that people can concentrate? Can you, okay, I'll ask you that all of you mute your videos as long as you can hear me, right? Okay, so we have root of 5 minus x minus x is equal to 1. But please take note, this minus x is not under the root. The minus x is not under the root. I'm on algebra. So I'm on algebra 2018 Gauteng. I sent everyone the notes, okay? All right, so the first thing to do, what's the first thing to do? The first thing to do, move this to the right. That means separate with the root. So the first thing is to separate with the root. All right, separating with the root. So what am I having? 5 minus x is equal to 1 plus x. 5 minus x is equal to 1 plus x, okay? All right, then from here, obviously, I need to remove the root by what? By squaring. Square both sides, I square there, I square there, right? Now, squaring both sides, this removes the root. So it will be 5 minus x, and then this side it will be 1 plus 2x plus x squared. That's what I'm having on my right, okay? Then if I take everything to one side, since the quotient of x squared is positive on the right, I'll take everything to the right. So that means 0 will be equal to x squared, rearranging this side, plus 3x, okay, minus 4, okay? Right, now factorizing this, right? So 0 is equal to, I factorize here, okay? I get x plus 4, and then I get x minus 1 there, all right? So either x is equal to minus 4 or x is equal to 1. But x is equal to minus 4 or x is 1. Okay, if that's the case, then I have to test which one of the answers is correct. If I take minus 4 and put it here, I have to test and put it there as well. I have to test if I get 1. All right? So you'll notice that if I take minus 4 here, it will be 5 minus minus 4, which is 5 plus 4, which is 9. Right, root 9 is 3. Then minus, then I take the minus 4 and put it there. So I'm now having 3 minus minus 4, which is 3 plus 4, which is 7. So that means on this side I have 7. By testing, I'm using minus 4 to test 7 is equal to 1. So that means minus 4 is not part of the solution. I go to x is 1. I put x is 1 here. So it will be 5 minus 1, which is the root of 5 minus 1. So 5 minus 1 is 4. Root 4 is 2. Right? And then minus, I put 1 there, 1. So 2 minus 1 is equal to 1. 1 is equal to 1. So that means the solution becomes that. So it follows that that becomes the solution. That becomes the solution. Okay? All right? Okay, let's proceed. I'm hoping that this is very clear. So the first thing, transpose, separate. The first thing is to separate. First thing is to separate. Okay? All right, let's proceed. So the next one that we choose here, please mind some noise a bit. My nephew is around, so it's a bit of a, okay. So we need to be as fast as possible. Okay, right. So the next one, let's look at this. Let's look at this type of a question, inequality, where there's an inequality. So we're looking at an inequality. This is the type of the question that we're looking at now. Okay, so inequalities are quite important, guys. You know, inequalities are very, very important. Okay, right? Let's go now. Okay. All right, I'm going to go to the next page there. Okay. All right, we have 6x squared minus 3x over 3 less than or equal to 3x squared. All right. Now, you notice that 3 can actually go into 6 and actually go into this negative 3. So this can be simplified to what? This can simply be simplified to 2x squared minus x less than or equal to 3x squared. Okay. Now, I noticed that this 2x squared is smaller than 3x squared. So let me take everything to the right. So 0 is equal to 3x squared minus 2x squared plus x. So, okay, so this is still less than or equal to. So 0 is less than or equal to, right? So we have x squared plus x. We have x squared plus x, okay? Right, now take note. Let me just take this to the left and take the 0 to the right. Remember, the sign is facing this, is opening to that. So it still has to open to that. So it will be x squared plus x greater than or equal to 0. Okay? Right, now when it comes to inequalities, always make the coefficient of x squared positive so that your graph faces up. Always make the coefficient of x squared positive so that the graph faces up. Right, so in the event that I took this to the left, let's look at that scenario where I took this to the left. It was going to be minus x. Okay, let me just write it with a different pen. It was going to be minus x squared minus x less than or equal to 0, right? But my coefficient of x squared is positive, is negative. I always have to make it positive by dividing by negative across. If I divide by negative across, it will be x squared plus x. Now, when you divide by negative, this sign becomes greater than or equal to 0. It changes when you divide across by negative. So this now looks exactly like this. So if you decided to just take this to the left, right, if you decided that, then it was going to be like this, but still, always make sure the coefficient of x squared is positive. Why do we do that? Okay, come here. Let's factor out the x here. It becomes x plus 1 greater than or equal to 0. Now, let me take this here. So what are our critical values? Right, critical values. Our critical values are x is equal to 0 and x is equal to negative 1. Those are critical values. Right, now check this out. Because my coefficient of x squared is positive, my graph is facing up. Right? Remember, there are many methods to do this. When my graph is facing up like this, okay? Right, I put my critical values, put minus 1 there, I put 0 there. Okay, I put minus 1, I put 0. Okay. All right. All right, so now this sign is saying greater than. When you're saying greater than, you're saying, where do we find y above the x-axis? This is a function. Greater than means above the x-axis. Remember, how many regions exist in an inequality? There's 1, 2, 3. 1 and 3 are always greater than or greater than or equal to 1 and 3. 1 and 3 are greater than or equal to, then this one is always less than or equal to, below the x-axis. So when you look at this sign is saying greater than. That means it's above the x-axis. So which regions am I taking? I'm taking region 1 and region 3. I'm taking region 1 and region 3. Okay, how do I describe region 1 and region 3? How do I describe region 1 and region 3? Right, region 1, I'm saying I'm going from negative 1 to negative infinity. So I'm simply saying x is less than or equal to minus 1. Because I'm going from that side to negative infinity. Then region 3, I'm from 0 to positive infinity. So I'm saying x is greater than or equal to 0. Remember, the less than or equal to, the greater than or equal to are coming from the or equal to here. If this did not exist, this or equal to was not there, then I'll remove it here and I'll remove it there. The answers will still be the same. This is the most important part, guys. Always make sure the coefficient of x squared is positive. Your graph will always be facing up. If your graph is always facing up, region 1 and 3, greater than, region 2, less than, always. Okay? All right, I think if that's the case then, if there are no questions, let's proceed. Let's proceed. Okay. So what we can do is just quick. We can actually let me just do that. All right, let's go to this one. I want you guys to do this inequality quick. I want you guys to do this inequality. Right, let's do this one. Right, let's do this one. On 2015 Metro. Let's do this inequality quick. Let's do that inequality very fast. Right, so we're doing that. Please be fast. It's 5 marks. It's 5 marks, so do that very quickly. Just use the method that I did. Just do it exactly like I did. Okay. Yeah, we're supposed to be done. This should be straightforward, okay? Okay. So this is saying x bracket x minus 4, right, greater than or equal to 21. Okay. First things first, right? First things first, you multiply them. So it will be x squared minus 4x, right? Now I can already transpose this to the left, minus 21 greater than or equal to 0. Okay, all right. Now, if that's the case, then I factorize this simply. Okay, remember factorizing can use any method here. All right, so it will be x minus 7, x plus 3, right? Okay, now let me think of my CVs, right? My CVs. So my CVs, x is equal to 7 or x is equal to minus 3. X is 7 or x is minus 3. Right. Remember, coefficient of x squared, positive. Graph facing up. Okay. There you go. Graph facing up. Critical values, minus 3, 7. I'm saying greater than. Which regions are greater than? I said, remember, there's region 1 and region 3. 1 and 3 are greater than above the x-axis. These are above the x-axis, region 2 is below. So if I'm saying greater, I'm talking about region 1 and region 3. What I simply need to do is to describe the regions. So I'm saying region 1 is where x is less than or equal to -3. I'm going that side. That's region 1. Right. Region 3, I'm saying x is greater than or equal to 7. Region 3, I'm going that side. So that's how you simply attempt that. Okay. Okay. So it will simply be that. All right. Let's proceed. I think this is quite clear. Okay. All right. Let's go back to the questions. Okay. All right. Let's look at this one now. Let's look at this one. Okay. All right. Let me do this one here. Okay. What are we saying here? All right. Let me first change this. So it's 2 times 3 to the power x plus 3 to the power x over 2 is equal to, now 7.5. This is like, remember 7 times 2, 14 plus 1, 15. It's like 15 over 2. So 7.5 is 15 over 2. So this is 15 over 2. Right, the problem here is this 2 denominator. So what do I need to do here? I can cross multiply. If I cross multiply here, it will be 2 times 2. It does multiply this 3 because it has an exponent which is unknown, x. So it only multiplies this 2 because it's 2 times 3. So it will be 2 times 2, which is 4, all right, times 3 to the power x. So the 2 doesn't multiply the 3, plus 3 to the power x is equal to, so what will happen here? It will be 15, it will be 15 over 2 times 2. So what will happen? That means this 2 and this 2 will cancel. The 2 and the 2 will cancel, okay? So if the 2 and the 2 cancel, what it means is now, what am I having? I'm having 4 times 3 to the power x plus 3 to the power x is equal to 15. It's called 15. I have 3 to the power x here, I have 3 to the power x. They're separated by a positive. So if they're separated by positive or negative, we can actually factor out 3 to the power x. If I factor out 3 to the power x, what remains is 4 plus 1 is equal to 15. 4 plus 1, 5. So I'll take it this side. 3 to the power x times 5 is equal to 15. I can divide across by 5. If I divide across by 5, divide across by 5, I'm having 3 to the power x is equal to 3. If 3 to the power x is equal to 3, remember 3 is to the exponent 1. Right, so same basis, what you do to the exponent, same basis are equating. What you do to the exponents, that means the exponents are also equal. So your x becomes 1. Your x becomes 1 then. So I'm having an answer for x, which is equal to a 1. All right, I suppose that's clear there. I suppose that's quite clear, okay? Right, so now let's go to, we're trying to cover everything as much as possible, all right? Let's go to the nature of roots. I understand, okay. Let me just get the questions here. Okay. I've unmuted one person there, they can talk. Okay, let me. Question?
Hi, sir.
Yes.
Can you hear me?
Yes.
Sir, could you please start over 1.1.4? I got lost somewhere. How did it become 4 times 3 to the power of x?
Okay, let me just run through that quickly. Right. Okay, let me run through that quickly. All right, so I said, remember, the 2 is a denominator here. So I said 2 times, this is 2 times 3 to the power x, this. I'm cross multiplying by 2, right? If I cross multiply by 2 there, it will be 2 times 2, 4, times 3 to the power x. Then cross multiply by 2 this side, it will be 15 over 2 times 2. But this 2 is a denominator, this one's a numerator. They cancel. Right, so that's why we're here. That's why we're here. Okay, then from here, 3 to the power x is common, 3 to the power x is common. I factor out 3 to the power x. What remains is 4 plus 1, which is 5. There you go, 4 plus 1, which is 5. I'm here now. Still 15 is still on the right. Then I divide by 5, divide by 5. So that means 3 to the power x is equal to 3 to the power 1. Therefore, x is equal to 1. Okay. All right. If we have the small book next to us, page 8, small book page 8, nature of fruits, small book page 8, nature of fruits, small book page 8. All right, small book page 8, nature of fruits. Okay. Okay, small book page 8, nature of fruits. You remember the quadratic formula, x is equal to minus b right? Minus b plus or minus root of b squared minus 4ac all over 2a. Right. Now, the nature of roots is determined by the discriminant. What is under the square root determines the nature of roots. What is under the square root? B squared minus 4ac. Right. So the nature of roots can be real. If they're real, that means b squared minus 4ac is greater than or equal to 0. If they're equal, that means b squared minus 4ac is equal to 0 if they're equal. Now, if they're real and unequal, that means b squared minus 4ac is greater than 0. So this one is real, or sometimes they say real and equal. Real or real and equal, okay? And then if they are rational, it's a perfect square. So if they are rational, it's a perfect square. So rational roots are a perfect square, okay? And then now the most, so if they're irrational, that means it's not a perfect square. So rational, this is perfect square, right? We know perfect squares, right? So perfect squares, right? Perfect squares are talking about 4, 9, 16, 25, 36, 49, 64, 81, 100. All those are perfect squares because 4 can be changed to 2 squared, 3 squared, 4 squared. That's why it's a perfect square. So that means if it's irrational, that means it's not a perfect square. Okay? And then if they're non-real, or we say they are imaginary. They're non-real or imaginary, right? That means b squared minus 4ac is less than 0. Remember, if this becomes less than 0, imagine what happens here. Even on your calculator, if this becomes less than 0, that means it's negative. That means if you say root of a negative, that means, I mean, we don't have a root of a negative. That's why they say they're non-real or they're imaginary, right? I think this should be clear. All right, let's just pick a question there. All right. Okay, so from the small book, okay, there's a question which says, for which values of k will the equation x squared plus x is equal to k. So I'm on small book page 9, 1.5, small book page 9, 1.5, have no real roots. No real roots. Right. No real roots. Remember, the roots are determined by the discriminant. Roots are determined by the discriminant, okay? The discriminant, okay? So for me to ascertain the discriminant, that means I have to put this in the form. A x squared plus bx plus c. I have to put this in this form. Is equal to 0. Okay, so that means I have to transpose this. So it will be x squared plus x minus k is equal to 0. Okay, then you say for non-real or no real roots, I know b squared minus 4ac should be less than 0 for no real roots. It's less than 0 for no real roots. Right, so I identify from here. What is my a from here? What is my a? What is my b? What is my c? Okay, a is equal to 1, coefficient of x squared. B is equal to 1, coefficient of x. What is C? C is always a constant, which is minus K. Okay, all right. B squared minus 4AC, I'm saying 1 squared minus 4. What is A? 1. What is C? Minus K. Less than 0. Okay, so I'm saying 1 minus minus plus. So 1 plus 4K less than 0. So transpose, because it says what values of K. So 4K less than, transpose this, becomes negative 1. That means K is less than negative 1 over 4. K is less than negative 1 over 4. K is less than negative 1 over 4. That's small page 9, question 1.5. So that's how. First, standard form, which is there. Identify your A, B, and C. Identify your A, B, and C. Then put them on your... So that means you have to remember this. You have to remember, in an exam, you have to remember when they say no real roots, because this is not on the formula sheet. No real roots, you have to remember that b squared minus 4ac is less than 0. They're non-real. They're imaginary. Are we together? Okay. All right. All right. Let's go now to the... let me just respond to these messages here on the oh, base is not the same. Okay. All right. Let's go now to the... I think that's straightforward. Okay. All right. Let's come here now. Let's look at this one. Let's look at this one. Okay. All right. So this is on page 3, the last part of algebra. The last part of algebra. Okay. All right. Let me do this. Okay. All right. Now let's discuss this one. Let's discuss this part, this one here. Let's discuss this. It says, given that, they say if P is 4, if P is 4, determine the nature of the roots. If P is 4, determine the nature of the roots. If P is 4. All right, so where there is P, we need to substitute 4. Where there is P, we need to substitute 4 there. Right, so it will be the root of 16 minus 4 by 4. So 4 by 4 is 16. 16 minus 16 is 0. So it will be root of 0, or the discriminant. What is under the square root? Remember, this is b squared minus 4ac. So that means whatever is under root is b squared minus 4ac. It's the one that determines the root, the nature of the root. So if you found out that b squared minus 4ac is equal to 0, then the question is, determine the nature of these roots. Right. Obviously, the roots will be equal. Because if b squared minus 4 is equal to 0, then the roots are equal. Right. So they're equal and rational. Remember, 0 is a rational number as well. So roots are equal and rational, because whatever is under the square root is the discriminant. And we found out that if we substitute 4, it will be 16 minus 4 times 4, which is 16 minus 16, which is 0. So whatever is under the square root, which is b squared minus 4ac, is equal to 0. That means the roots are equal because it's equal to 0. Equal and rational. Equal and rational. Then this one says, the next one says, determine the value or values of P for which the roots are non-real. If the roots are non-real, If the roots are non-real, it's the same as what we did earlier. If the roots are non-real, then I'm saying 16 minus 4p should be less than 0. The discriminant, whatever is under the square root, should be less than 0 for non-real. Right, this is a discriminant, remember. The discriminant, this is a discriminant. So the discriminant is just p squared minus 4ac. It's a triangle. Okay, then making my p subject of formula, right, what do? I will say minus 4p is less than minus 16. Minus 4p is less than minus 16. Dividing by minus 4, dividing by minus 4. What happens to the sign when I divide by minus 4? It changes, so p is greater than minus 16 over minus 4 is 4. So p is greater than 4. So for these roots to be non-real, p has to be greater than 4. For the roots to be non-real, p has to be greater than 4 for the roots to be non-real. Are we together? Okay. All right, so we're trying to rush, guys, as much as possible. We're trying to rush as much as possible to cover everything. At least this part is done. Now, when it comes to simultaneous equations, remember, if I were to touch simultaneous equations a bit, okay. Okay. Right, so for simultaneous equations, right, so if you have simultaneous equations like this, remember the first thing to do is, the simplest to make subject here, if this is equation 1, 2, right, now from equation 2, I can see that there's x squared, then there's 8y. It will give me fractions and it's complicated. From equation 1, I can make either x or y subject, but x has a coefficient of 1, so it's the best to make subject. If I make x subject, I'm saying x is equal to 2 minus 2y. X is equal to 2 minus 2y. Then this will be my equation 3, which I then substitute into equation 2, where there is x. So my substitution will be 2 minus 2y squared, where there is x, plus 8y is equal to 8. Expand this, factorize, standard form, factorize, equate to 0, solve for y. After solving for y, whatever y values you get, you come and substitute there to get your corresponding x values. To get your corresponding x values, okay? All right, I think that will be clear. And then sometimes, you know, with exponents, sometimes they, with simultaneous equations, sometimes they bring them with exponents. Like you can see on page 8, of the small book, 1.4 and 1.5. So those ones also, you need to look at them where they bring simultaneous equation with exponents. We did this in class as well, if you remember. Page 8, small book, question 1.4 and 1.5. You need to look at those. So they bring them standard like this, or they bring them with exponents. So you need to look at this, 1.4 and 1.5, okay? All right, let's move. We have 2 hours. We need to cover everything. Let's move, okay? All right, let's do that. Clear there. Okay, we move. Okay, functions. So with that question on functions there, I hope everyone has it in front of them. Okay. All right, now let me just try to, right, so with functions, okay, this is a hyperbola. This is a hyperbola. Right, so with a hyperbola, you can be either given the diagram and asked to find A, P, and Q, or be given the equation and asked to sketch between the two. So you can be given an equation or asked to sketch, or be given the sketch and asked about the equation. Okay, all right. So you need to look out for this as well. Look out for this. Now, if we're to discuss this, now it says, so we're given F. F is a straight line. F is a straight line there. There's your F, straight line. All right. Now, the equation of F is minus 2x plus 2, and G is given by that. And then they told you that the graph of G casts the y-axis at 0 and 4. It casts the y-axis, so at 0 and 4. So there, 0 and 4. The coordinates there, 0 and 4. Okay. All right. Now, if that's the case, then now let's talk about finding P and Q. Remember, P and Q are the asymptotes. P and Q are the asymptotes. P and Q are the asymptotes. Okay. All right. So in this case here, now the vertical asymptote represents P. The horizontal asymptote represents Q. But how do I find this? I noticed that the y-intercept of the straight line will give me the y-asymptote. The x-intercept of the straight line as well will give me the x-asymptote. So what do I need to find? I need to find the y-intercept and the x-intercept. I need to find the y-intercept and the x-intercept. All right. Now, how do I find the y-intercept? Where the graph crosses the y-axis, x is 0. If I say x is 0 there, my answer becomes 2. If I say x is 0, my answer becomes 2. Right. If y is 0, to get the x-intercept, y is 0. So it will be 0 is equal to minus 2x plus 2. Then transpose the minus 2. Minus 2 is equal to minus 2x divided by minus 2 divided by minus 2. X becomes what? X becomes 1. That means here x is 1 here. So this equation of a straight line has helped me to find the asymptotes. So what is my P? What is my Q? Right. So the equation now looks like this. So it's g of x is equal to a over x. Right. So if P is 1 here, that means here it's minus 1. So on the diagram, if it's 1, then there's a sign change there. Okay. And then plus Q has no sign change, it's 2. So that means P is equal to -1 and Q is equal to 2. Okay. Then the second question says, show that A is minus 2. Now, the only unknown is A. How do I find A? I substitute any point. There is my B there. I'm given that B is coordinates 0 and 6. It's the y-intercept of the hyperbola. Right. So I would say 4, that is y, is equal to A over x is what? 0 minus 1 plus 2. Okay. Transpose the 2 to the left, it becomes 4 minus 2, which is 2 is equal to A over minus 1. Because multiplied by minus 1, A is equal to minus 2. There is your minus 2 there. Are we clear? Right. So in the event that the questions come like this. Now, this is a scenario where we are given the graph. What if you're not given the graph, you're asked to sketch? There is a question on the small book, on functions on the small book, page 29. Small book, page 29. On the small book, page 29. There is a question there on the small book, page 29. Okay. So on the small book, page 29. Right, small book, page 29. Class exercise 1, where you're told to consider f of x is equal to 2 over x minus 3 plus 1. Okay. Just responding also to. Okay. Okay. Right. So if it's like this, if it's given like this, then the first question is saying, write down the equations of the asymptotes. Write down the equations of the asymptotes. Right. What are the equations of the asymptotes? The x asymptote and the y asymptote. So x asymptote, you take the, actually someone was asking me this question, so let me answer it already here. X asymptote, right? You take the denominator, x minus 3 equate to 0. So for x, what is x? 3. So the asymptote is x is 3. Take the denominator, equate to 0. So for x, so x is 3. That's the x asymptote, the vertical. Then the horizontal one, y is equal to +1, as it is. The horizontal one is no sign change. The vertical one is a sign change. All right. Then it says calculate the coordinates of x and y intercepts. x and y intercept, remember, x intercept, y is equal to 0. X intercept y is 0. Make y 0 there. So x intercept y is 0. So 0 is equal to 2 over x minus 3 plus 1. First transpose to the left, it becomes minus 1 is equal to 2 over x minus 3. Cross multiply, it will be minus 1 multiplying x minus 3 being equal to 2. So it will be minus x plus 3 equal to 2. Right, so to find my x, I can take this to the right or take the x to the right and the 2 to the left. So it will be 3 minus 2 is equal to x. That means x is equal to positive 1. Okay, x is equal to positive 1. Okay, that's the x-intercept. Okay, if I come to the y-intercept, okay, I see there are 2 hands raised there. All right, I'll start with one of you guys here. Okay, let's ask quickly. Okay, all right, let me ask someone else to unmute here.
Hello, sir, can you hear me?
Yes, I can hear you, Lebron.
Okay, so I'm sorry, I have a question on functions. So what if you are given like the equations of x's of symmetry, then you're asked to find the function?
You're asked to find the?
You're asked to find the function, you're asked to find p and q, or you're asked to show that p and q are
yes, that's what we're doing, remember, on that question, on the handout that I sent.
Yes,
because
sir.
we first found, to find P and Q, you notice that we use the equation of the straight line to find the x-intercept and the x-asymptote and the y-asymptote. That's what we did, the previous question.
Okay, so we use the same approach.
Yes, but this one is different because we had to first find the x and y asymptotes. Then we put them on P and Q.
So in this case, we are given the equations of x's of symmetry.
Sorry?
In this case, we are given the equations of x's of symmetry.
You are saying if we're given the equation of x of symmetry, remember the equations of x of symmetry pass through the intercepts of the asymptotes.
Yes, sir.
Yes, so they can also help us to find the equations of the asymptotes.
Okay, sir.
Yeah.
Thank you.
All right. Okay, so I'm trying to juggle everything and respond to people as well. Okay, all right. So y-intercept x is equal to 0. So x becomes 0 there. Y is equal to 2 over 0 minus 3 plus 1. Right, so it will be y is equal to, right, this is minus 2 over 3. Remember, if the minus is there or there, it doesn't matter, plus 1. So y is equal to a third. Okay, so y-intercept a third, x-intercept 1. Y-intercept a third, x-intercept 1. Right, then obviously when you're sketching, you start with the asymptotes. So when you're sketching, you start with the asymptotes. Asymptotes, then followed by the intercepts. And remember, this is your A. If A is greater than 0, if A, let me just write it with a different color. If A, this is A. If A is greater than 0, you know that your graph is on the first and the third. Then if A is less than 0, I know that my graph is on the second and the fourth. So I know that this graph will be on the first and the third, this one, because A is greater than 0, first and third. So my graph will be on the first and the third. Then you sketch your asymptotes first, then your intercepts. Okay? All right. Let's proceed. Okay, now let's look at the next question, which is the parabola. We are given a parabola. Okay, right, there we go. Right, there is our parabola there. Right, so with the parabola, the first thing you ask yourself is, what am I given? Right, remember, there is the intercept form and the turning point form. The intercept form is y is equal to a, x minus x1, x minus x2. Here you'll be given intercepts. This is the intercept form, intercept. Right, so this is the intercept form. Then there's a turning point form, y is equal to a, x minus p squared plus a q, where the turning points are p and q, sign change. Turning points are p and q, sign change. Okay, turning points are p and q, sign change. Right, now look at this question. It says the graphs of f and g are shown. The turning point of f is, there's a turning point of f there, and the graph of f and g intersect at b. At b, there is a b. C is a point on G. So C is a point on G and is on the axis of symmetry. Very important information. Is on the axis of symmetry. Okay. Now, if we were to discuss the axis of symmetry, the axis of symmetry passes through the turning point. The axis of symmetry passes through the turning point. So, what is the equation of axis of symmetry? The equation of axis of symmetry is given by x is equal to minus b over 2a. Minus b over 2a. That's the equation of x of symmetry. But this is also how you find the coordinates of the turning point, the x coordinate of the turning point. The x coordinate of the turning point, the x1, you say minus b over 2a, which is the same thing as finding the equation of the x of symmetry. So these are the same. Why? Because the x of symmetry passes through the turning point. The x of symmetry passes through the turning point. Okay? Now, this question says, show that the function f is defined by the equation. Show that the function f is defined by the equation. Okay? Right. Let's see. So, what information are we given here? I can see that I'm given turning point, and I have a random point here. So, I can make use of this equation because I have a turning point and a random point. This I use when I have intercepts. This one. Intercept form. I use when I have intercept and a random point as well. But here I have a turning point and a random point, so I use y. Y is equal to a, x minus p squared plus a q. A, x minus p squared plus a q. All right? Let me just get my here. Right? So, first I substitute my turning point. Y is equal to a, x, right? This is 2 here. So it becomes minus 2 squared plus q. Q goes in as is, 9. X was 2, and it comes here, it becomes minus 2. Okay? Now I need to find a. How do I find a? I substitute a random point with coordinates 3 and 8. Random point 3 and 8. So 8 is equal to a. 3 minus 2 squared plus a 9. Okay, I can transpose here to the left. It becomes 8 minus 9. It's minus 1 is equal to a multiplied by 3 minus 1. 3 minus 1 is 2. So 3 minus 2. So 3 minus 2 is 1. 1 squared is 1. That's 1 here. That means my a is equal to minus 1. My a is minus 1. Then what do I do with this a is minus 1? I take it and substitute it there. I take the a and substitute there. Okay. What does it become? Please take note that the memo will be sent to you as well after the lesson, so don't stress. The memo will be sent after the lesson as well. Okay. Right. So it will be y is equal to, I'm substituting minus 1. Minus 1 x minus 2 squared plus 9. Simplify. Y is equal to minus, then this becomes x squared minus 4x plus 4 plus 9. Okay, the minus is outside. Then multiplying by minus inside to be minus x squared plus 4x minus 4 plus 9. So it will be y is equal to minus x squared plus 4x plus 5, which is the same as there. Which is the same as that, okay? Now, write down the equation of the axis of symmetry. We've discussed already the axis of symmetry. The axis of symmetry passes through the turning point. The axis of symmetry passes through the turning point. So this is my axis of symmetry. It passes through the turning point. What is the x coordinate of the turning point? It's 2. So the equation of axis of symmetry is x is equal to positive 2. That's why it's 1 mark. Equation of x of symmetry is x is 2. X is 2. Okay? Right. Raise that. Right. Please take over, trying to cover as much ground as possible. All right. 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 The graph. All right. So the graph of G has the equation y is equal to a to the power of x. This is exponential. Determine the value of a. Determine the value of a. So determine the value of a, you need to check. I need y and x. That means I need a random point. Which random point am I getting? Where the graph of G passes through. I see that I have this. G passes through 3 and 8. So where there's x I substitute 3, where there's y I substitute 8. So 8 is equal to a to the power of 3. Right, I'm here now. Right. I'm looking for the base. My exponent is 3. Am I able to change 8 to have an exponent of 3? Yes, I can. By saying 2 to the power 3 is equal to a to the power 3. Now I've made the exponents to be the same. As soon as you make the exponent to be the same, that means the bases also are equal. So your a is 2. Your a is 2. Okay. A is 2 there. So substitute random point, then make the exponents to be the same. Equate the bases. If it was the other way around, where you have to, let's say you are given that 8 is equal to, let's say, 2 to the power of x. Let's say you are looking for x. Obviously, this will be 2 to the power 3 is equal to 2 to the power x. Then your x becomes 3. So you can use it the other way around as well. Okay. All right. Let's proceed. All right, let me clear this. Okay. Stop there. Then I move down. Okay, yes, we're coming here. Yeah. Okay. Then it says, just do it like this, okay? Right, so we're trying to, I think we're on time. In terms of time, we're still a bit okay. All right. Now it says, for which, okay, it says, if it is given that minus 1 and 0 is 1 root of f, minus 1 and 0, that means it's minus 1 here, is 1 root of f. Remember, root is the intercept. Write down the coordinates of the other root. Write down the coordinates of the other root. Write down the coordinates of the other root. Okay. Okay. Right, write down the coordinates of the other root. Now let's look at this, guys. If this is minus 1, we're looking for this one. That's what you're looking for. Now, if this is 2, remember, an axis of symmetry divides the graph into 2 equal parts, equal. If it's equal, that means from here, if I were to walk to there, I should walk the same distance from here to there. That's what it means by equal. So the axis of symmetry divides the graph into 2 equal parts. So what you need to ascertain is now, you need to ascertain what's your distance from there to there. If I walk from minus 1 to 2, how many units do I walk? Let's walk together. From minus 1, I walk to 0, the origin. This is 0, the origin. From minus 1, I walk to 0, I've walked 1 unit. From 0, I walk to 2, I've walked 2 units. So here I walk 1 unit. Here I walk 2 units. So in total, I walk 3 units. This side. That means this side I also have to walk 3 units. So what is the coordinate here? It will simply be 2 plus 3, which is 5. So always be able to use symmetry. What I'm using here is called symmetry. I'm using symmetry to determine the roots. So you can always use symmetry to determine the roots. If you're given one root and you know the x of symmetry or the turning point, if you know the x of symmetry or the turning point, then you can find the other root by using symmetry. If this is -1 to 2, I walk 3 units. That means from 2 to 5, I have to walk another, I walk 3 units. So from -1 to 2, I walk 3 units. That means I also have to add another 3 units from here to here. So 2 plus 3, 5. So that means the coordinates of the other root, 5 and 0. Okay. Then for which values of x, these are interesting questions. For which values of x will f of x be less than 0? When you say f of x is less than 0, what do you mean? F is y. When you say f of x is less than 0, you're saying y is less than 0. We are saying below the x-axis. This is very important, guys. Very, very important. Below the x-axis. So if you're saying f is less than 0, you're saying y is less than 0. You're saying below the x-axis. So where do you find this graph below the x-axis? That's what it means. Where do you find the graph below the x-axis? Remember, we said this is -1. We said this is 5. Right. So where do you find the graph below the x-axis? Let's follow it. Do you notice that here, this part is below and this part is below? But this part is below going where? To negative infinity. This part is below going to positive infinity. So here I'm going to positive infinity. Here I'm going to negative infinity. It's below. All this part here is above. I don't want this part which is above the x-axis because it's for y, it's for f greater than 0. I don't want this part. I want the part where it's less than 0. Now, how do I then define this region from -1 to negative infinity? You define it as x is less than -1. X is less than -1 because it's less than -1. Or if you want, you can say, x is greater than negative infinity, but x is less than -1. But it's the same thing. It's the same thing. All right. Now, we have defined this region where it's less than 0. And let's define this one. So from 5 to positive infinity is below the x-axis, is less than 0. That means also you say x is greater than 5. So from 5 to positive infinity is less than 0. Or you can say x is greater than 5, but less than positive infinity. But you don't need this. You notice, you just need to say x is greater than 5. Because if you say x is greater than 5, we know that means it's less than infinity because it can never be equal to infinity. All right. Okay, it's 10 o'clock. We need to rush. Okay. So that's how you define this. So let's say if the question had said f of x greater than 0. Greater than 0 is above the x-axis. So it will be from here all this way to there. That's where f is greater than 0, above the x-axis, above. How do you define it? You say x greater than -1, but x less than 5. That's how you define f of x greater than 0. Okay. All right, quick. Let me just take questions here. Okay, let me lower this hand. All right. Hello?
Sir, can you hear me?
Yes, I can hear you.
Okay. There's this other questions that was like multiply f of x times g of x.
Okay, I'm going there. Yes, f of x times g of x greater than 0 or less than 0, right?
Yes. Yes, what do you do?
I'm going there actually. I'm going there now.
Okay. Thank you.
All right. Thank you. All right. Right. Determine the length of AC. Determine the length of AC. Okay. Let me do this. Right. Determine the length of AC. Okay. Right. determine the length of AC. Right, AC. Okay, C is on what? C is on G. C is on G. Right. Now, what is the y coordinate here? Is 2. We need to find the y coordinate here because we know the x coordinate is 2. Let's find the y coordinate. Let's find the y coordinate. Right. What did we find as the answer for A? Or answer for A, we found the answer for A as 2, right? We found the answer for A as 2. Okay. So the equation of G of x is equal to 2 to the power x. Right. So what is the y coordinate here? Where x is 2, that means substitute 2 here. So we find G of 2 to the power 2. So this is 4. So the y coordinate here is 4. That means this distance AC is, that means AC is 9 minus 4. 9 minus 4. AC is equal to 5 units. Right. So I simply define, because this is a vertical line, I simply define the y coordinates difference. So the distance AC is the difference here between 9 and 4, which is 5. That's AC, 5. Okay. Determine the nature of the roots. Determine the nature of the roots of f of x minus 9. Right. What does f of x minus 9 mean? What does f of x minus 9 mean? F of x minus 9 means from this function, you're subtracting 9. That's f of x minus 9. And it simply means this graph is a translation of 9 units vertically down. If the graph is a turning point already of 2 and 9, then that means you subtract from the turning from 9 here. It will be, so the coordinates of the new function, the turning points of the new function will be, let's call it A prime. Let's call it the coordinates of the new turning point A prime. There will be 2, 9, minus 9. This minus 9 means is this one, the turning point here. So what are the coordinates here? It will be 2 and 0. How does the graph look like? It moves vertically down 9 units. If it was at 9, that means it moves to here. So the turning point is like this. So the graph is now like this, turning there. So what are the roots here? Because it's now turning on the axis. The roots are equal. That means the roots are real and equal. So the roots, real and equal. So the roots are real and equal because now they're equal to 0. Because they are equal to 0. It's now turning on the axis. So the roots are real and equal because it's now turning on the axis. All right? Okay, someone is asking, so when we're translating, we look at the turning point. Right. For a parabola. So we're going to the translation now of parabola. We're going to the translation, so we're going there. Okay. All right. So there's this part here. Someone was asking about this part. Then we come to the translations. All right. Now let's come to this part. This is, guys, the most important part. Very important. This is very important. Right. So when you come to this part, we don't necessarily need to know the equations. These equations, they don't help us. We don't need to know these equations. Okay. All right. Okay, I'm having right. Someone is saying we explained 3.7 again. So the graph moved 9 units. So if you're saying f of x minus 9, that means you're translating the graph vertically down 9 units. So that means the turning point, if it was at 2 and 9, we are subtracting from the, because it's a vertical translation. Remember, f of x minus 9 is affecting y. So you're moving 9 units vertically down. But f of x minus 9 is inside the bracket. That means the graph is moving 9 units to the left, horizontal to the left. If it's inside the bracket, it's horizontal. If it's outside the bracket, it's vertical. Okay. All right. So we are going there actually. I'll explain that part. But let's come here. Right. Time is really killing us now. Okay. Right. Use the graph to determine the values of x for which f is equal to g. F is equal to G. That means where they're equal, where they intercept. F is equal to G. So 5.1, where F is equal to G, where they're equal, that means where X is equal to -2 and X is equal to 4. They're equal. The graphs are equal here. Okay, right. This is now what one of you guys was asking. Right, listen carefully, this part. It says f of x over g of x greater than or equal to 0. Now, this part is the same, guys. This is the same as when the question is asked like this: f of x times g of x greater than or equal to 0. These two are the same. These two are the same, guys. They are the same. The approach is the same. How you answer it is the same way. Division and multiplication, they'll give you the same result. So how do you answer such questions? You use signs. You use signs, right? You use signs, okay? Right. So you're saying, for this to be greater than or equal to 0, that means it's positive. For f over g to be positive, that means, what are the signs for them to be positive? That means greater than or equal to 0, all right? For them to be positive, that means it's either it's a positive over a positive, or it's a negative over a negative. Remember, positive over positive is positive. Negative over negative is positive. Then, what are you saying? What are you saying when you're saying the graph of f is positive? A graph is positive above the x-axis. A graph is positive above the x-axis. And a graph is negative below the x-axis. So what this question is asking is this. Listen here very carefully. Where do you find the graph of f above the x-axis? At the same time, the graph of g also above. Where do you find both graphs above the x-axis? So literally close this part which is below. You don't want it. You want the part where both graphs are above. Do you notice that from here, all the way f is above and also g is above? They go, f is above, and g will be above to positive infinity. So we have to check f only because g already is above up to positive infinity. Right, so the parts where both graphs are above is from -2 to 6. Both graphs are above from -2 to 6. And this is same or equal to. So our answer will be x is greater than or equal to -2, but x is less than or equal to 6. So greater than -2, less than 6. So this part, both graphs are above. Okay, sometimes you might need to combine. I prefer combining and say -2 is less than x, x less than or equal to 6. You can combine, but most students actually prefer that, where they say x is greater than or equal to -2, but x less than or equal to 6. So what it means is we have covered this part only. Listen carefully, we have covered this part only. Let's come to this one. Where do you find the graph of f negative below the x-axis and the graph of g also below? Both graphs below. So if I'm saying both graphs below, that means I don't want the part which is above. If I'm saying both graphs below, that means I don't want the part which is above. I'm looking at the parts where both graphs are below. Do you notice that from here to negative infinity, g is below, and from here to negative infinity, also f is below. That means this part from here going that side, both graphs are below the x-axis. They are negative. That means what we say in terms of x? We say x is less than or equal to -2. Both graphs are below the x-axis. Both graphs are below the x-axis. Okay? Right. I think this is clear. So you take plus, plus, minus, minus. So if the question had said f of x times g of x greater than or equal to 0, it will still be plus times plus or minus times minus. It will still be the same. Then if the sign is less than or equal to, that's why it changes. Let's say the sign is less than or equal to, or less than. Let's just take less than. If it's less than, that means, where do I find the graph? How do the signs look like? It's either the graph of f is positive while this one is negative, or the graph of f is negative while this one is positive. So the question is, where do I find the graph of f above the x-axis while the graph of g is below? So f above, g below, that's less than 0. Or f below, g above, because these signs multiply and give you a less than 0. Okay? Okay. All right, let's do that. And then we go down. We go down a bit. No, my graph is not going to be visible. Okay. What do we choose there? Okay, all right, I'm okay now. Just a bit, just an inch. Right, 100%. Okay. All right, now f prime times g, f prime. This is calculus. F prime times g greater than or equal to 0. F prime is gradient, guys. F prime is gradient. F prime is gradient. That's the golden rule of calculus. F prime is gradient. Okay. Right, F prime. So when you're saying F prime, you're saying the gradient. So the golden rule of calculus, I know we're here to get there. The golden rule of calculus is F prime is equal to the gradient. This is a golden rule of calculus, golden rule. When you think of F prime, I know it's the first derivative, but it's the gradient. So when you're saying F prime, remember this sign is saying greater than or equal to 0, that means it's positive. So you're saying, where do you find the gradient positive and the graph of G above the x-axis? Or where do you find the gradient negative and the graph of G below? Remember, negative gives you positive. Positive gives you positive. So where do you find the graph of F or the gradient positive at the same time G above the x-axis? Remember, a gradient is positive like this. If you're looking at a parabola, this is uphill, positive gradient, uphill. At the turning point, the gradient is 0. Then downhill, the gradient is negative. So look for the part where the gradient is positive and G is above the x-axis, positive. Gradient positive, G above the x-axis. Right, do you notice that here, all this way, gradient is positive, but G is below. But when you get here, gradient is positive and G above. Positive gradient, G above, positive gradient, but until just before 2, because at 2, the gradient is 0. When I'm now this side, the gradient is now negative. I don't want this part, even if G is still above, positive, but for me, the gradient is now negative this side. So between -2 and 2, uphill, G above the x-axis. How do I write it? I'll say x is greater than or equal to, x is greater than or equal to -2. But x is less than 2. I don't say or equal to, because at 2 is a turning point. The gradient is 0. So uphill, between -2 and 2. G above the x-axis, between -2 to positive infinity. So I break here, I end here. I end here. Okay? So I've done this part. So I've done this part. Let me look for this one. Where it's downhill and G below the x-axis. Downhill and G below. This does not exist because G is always above. So this does not exist where it's downhill. Yes, I see a downhill here, but G is already above. It's positive. So this one does not exist. So you throw it away. So your answers are these for that. Okay. Let's move. Okay, we move. See there. Let me just check. Hey, someone is saying, guys, let's not write things like Ola gents. You know what? It's not necessary here. I see someone is greeting people here on the chat. Let's not write unnecessary things, guys. Okay, right. Right. Let's go to the next one. Then you go to transformations. Okay, so now what is this one saying? It's saying f greater than g. Right, this one is saying f, okay, let me use right, so f greater than g means f above g. F greater than g means f above g. Okay, so where do you find the graph of f above g? F above g, right? Do you notice that here is g above f? F is below. When I get here, they're equal, right? When I'm now moving this side, do you know that f is now above g? G is below, f is above. So between -2 and 4, f is above g. So between -2 and 4, so you say for x is greater than -2, but x less than 4. X greater than -2, but x less than 4. That means f is above g, literally above, right? Then let's come to this one. Where do you find f below g? F below g. F below g, okay? How did you see that g is above f? All right, someone is saying, how did you see that? Okay, we're going here, where g, where f is below g, that means g is above. So when you're saying g is above, this line, look at the line, it's literally look straight on the graph, okay? Let me just do this now, okay? Let me just come back here. I want you to see something where f is above. F, look at the graph. This line, this part is below. This one is above, like literally above. Look vertical. Okay, let's say look vertical. This is below, this is above, vertical. So where does f start to be? Where does f start to be above? From here, all this way, it's above, up to here. So now when we're answering this second one, where f is below g, f is below g. So where f is, here they're equal. Look at this part. F is now below because g is above. G is above. So for x is less than -2, here, f is below, g is above. And also, when I pass here, do you notice that all this way, f is above? We don't want f is above. We want where f is below. There you go. F is below here. F is below and g is above. So for what values of x? For x is greater than 4. So from 4, if I move that side, that means g is above, f is below. G is above, x is okay. All right, that's the case. So we have answered that. So f above, g below. Okay. All right. Want to look at transformations, right? Transformations. Okay. Okay. All right. Transformations, right. Now I introduced this part here, transformations. So when you're saying f of x minus c, you're saying it's a horizontal translation of c units to the right. Whenever it's inside the bracket, it's moving to the right. If it's negative, it's moving to the right. If it's positive, it's moving to the left, but it's horizontal. So what it simply means is you just say, just a moment. So what it means is you just say x minus c is equal to 0. What is x? X is equal to c. So the movement is c units positive. So when it's negative here, it moves positive. That's the movement. So when it's positive here, it moves negative. That means it moves to the left. When it's positive inside and it's horizontal, it affects the x, affects the x, affects the x. Then this one, when it's outside, when you're saying f of x plus d, it's vertical upwards, vertical upwards. It's vertical upwards. Okay, it's vertical upwards. So it affects the y. So this affects the y. This one affects the y. right? So if it's f of x minus d, that means it's vertically down. Vertically down. Okay? Right, so how does it affect the turning point? How does it affect the turning point? Okay? Right, so if I were to, okay, if I were to, all right, let me do this. I need to clear this. Okay. If I were to come here, right, let me come here. Right, if I were to come here, this is a turning point. Right, let's say they say find the coordinates of the turning point of f of x plus 3 minus 5, right? So they want us to find the coordinates of f of x plus 3 minus 5, right? If the coordinates here are 2 and 9, that means you say 2 minus 3, then plus 9 minus 5. Check note, this minus 5 is the same sign, but this 3 was positive. It has to be negative because this 3, remember, the movement is the other side. Are we clear? Okay, so the movement, okay? So that means if you're moving it to the left. So it will move 3 units to the left. So the coordinates will be, actually I should have done like this, just do like this and say like that, okay? So the coordinates are minus 1 and 4. So that means it moves 5 down, 3 to the left. So you expect the graph to be like this. Minus 1 and 4. 5 down, that means it goes to 4. So here, left. There, down. Vertical, horizontal, but to the left. So there's no sign change on y, but there's sign change on x. Okay? Yeah, so that's about transformations. These notes are the ones on transformations are actually there on the handout that I shared on the group. Okay? So these notes are on the handout and they are actually explained here. So you need to, after class, go through this. It's well explained, the notes, well explained. Right, then you'll need also, let's look at this part. There's a part that I need here where we talk about the inverse. Right, the inverse, okay? Right? Right, so to show that the graph of G, I think that one we can do that. For which values of X is the graph of F strictly decreasing? The graph of F, this is the graph of F. Right, so this point here, right, for it's strictly decreasing. Right, now for values of X from minus 2 to 0, the origin, the graph is decreasing, negative gradient, decreasing, negative gradient. So from minus 2 to, so minus 2, actually, let's put it this way, the way you guys prefer it. So you say it's strictly decreasing for X is greater than, right? So it's greater than or equal to, because minus 2 is included, minus 2, but X less than 0. You exclude 0 because 0 is a turning point. At 0, it's not decreasing. It's stationary at 0. It's not decreasing, it's stationary at 0. Okay? But for X greater than minus 2, greater than or equal to, but less than 0, is decreasing. Right. Then it says determine the inverse of F in the form F inverse. Determine the inverse of F in the form F inverse. Right. What is F? There is your F given. Right. In the form F inverse. Right. So f of x is equal to a quarter x squared. Remember, how do you find the inverse? First, f changes to y. Then you swap. Where there's x, put y. Where there's y, put x. So this is x is equal to a quarter y squared. Like a quarter y squared. Then make y subject of formula. Make y subject of formula. Right, making y subject of formula, that means this 4, remember, is a denominator. I can cross multiply. So it will be 4x is equal to y squared. Now to find y, I have to find the root. So y is equal to plus or minus the root of 4x. Y is equal to plus or minus the root. So y is equal to plus or minus the root of 4x. Right, now I can go further because I know root of 4 is 2. So it will be plus or minus 2 root x. Plus or minus 2 root x. Okay? Now, they say it in the form of y, so this is fine. So y is equal to, that will be your answer. Swap, make y subject. Swap, make y subject. That's the inverse. Right, now sketch the graph of f inverse. Sketch the graph of f inverse. Right, sketch the graph of f inverse. This is the interesting part. Remember, this is a parabola. This is a parabola. Okay, now always do this, guys, with a parabola. Always sketch the line y is equal to x. Always sketch the line y is equal to x. It makes it easier for you to see the graph, how it reflects. Remember, it has to reflect about line y is equal to x, okay? Now, if I were to draw my graph, this part here should reflect like this. This part, look, it's a mirror. Then this part should reflect on the 4th quadrant. Right. Okay. Let me just do this, try to perfect it a bit. Right, so it ends somewhere there. Right, so remember, if I were to put this point for x is -2, it swaps to -2 for y, swaps. So this graph ends at -2 there. If this was -2 there, that means it ends here at -2. It ends at -2, okay? All right. I hope this is clear, right, guys? Okay, so that's the sketch of the inverse. Always draw this line so that you can see that this mirrors this side. This mirrors the other side. So this is your F inverse. Okay. All right, this should be clear. Okay. All right, we're left with 30 minutes. I think we're on time. Right, okay. All right. Someone is saying 3.1. Which 3.1 are you talking about? 3.1. I did, or 6.1. I didn't do 6.1. We can actually do, I don't think it's a problem to do 6.1, to do, I don't know if you meant 6.1. Guys, some people are asking which paper is this. This is a handout that was shared on the groups, guys. When I shared the link, I shared the handout on the group. Please go to your WhatsApp, check this handout. All this is there on the handout, okay? Okay. All right. Okay. All right. Someone saying, how did you draw the inverse graph? Right, guys, the inverse graph, first thing, the line y is equal to x. First is the line y is equal to x. The line y is equal to x. Right, this is also there, guys. If I may just, it's also there. How you draw this graph, it's also there on page 46 and 47, small book. 46 and 47, small book. It's there, 46 and 47, small book, okay? Right, the graph is like this. So what it means is this, guys, if I were to draw it like this, right, let's say this is the line I was called X. Always draw it first. If there's a part that is this side, it will reflect the other side. That's what it means. And if your part that is this side, then it reflects this side. Okay? But remember, also, you can restrict the domain of this to get it, because remember, if this graph here, as I drew it here, remember I drew it like this. The inverse as it is not a function, remember. If I do a vertical test, this inverse is not a function. But it's a function when I restrict the domain. If I restrict the domain, we did this on page 47, small book, page 47, small book. If you restrict the domain of the original, that means its inverse will be a function. Right, if you restrict the domain, meaning, if you're restricting the domain and I'm saying, let's say you draw the graph of, okay, let me actually do this. I'm going to go through this very quickly, restricting the domain of a parabola. Okay. Right, restricting the domain of a parabola. So on page 46, 47, right? If I'm restricting the domain of a parabola, let me just try to do this. Okay, there. Okay, right, let me draw my parabola. Y is called x squared. The graph of y is called x squared like this. Its inverse is like this. Its inverse is like this. This is inverse. It's not a function. Right, if I do just draw the line as project, this inverse is not a function, because if I do a vertical test, it will pass how many times? 1, 2, which makes it not to be a function. It's inverse. It is an inverse, but the inverse is not a function. So how do you make the inverse of a parabola a function? You restrict the domain. Restricting the domain meaning, remember, this is a graph of y is called x squared. For x is a set of real numbers. That means from negative infinity to positive infinity. Okay? Right, so restricting the domain means I'll do this. Right, restricting the domain means I can draw the graph of y is equal to x squared. This is graph of y is equal to x squared for x greater than or equal to 0, this side. Right, now let me draw the line y is equal to x, and you see how it reflects. That means this part here, I've not shown it. Then this parabola will have an inverse, which is a function, because this is the inverse. This inverse is y, right? This thing is y equal to root of x. Right, so that will be y is equal to the root of x. Okay, so you have restricted the domain. This is a domain restricted. So if I were to draw this side, it will be y is equal to x squared for x less than or equal to 0, this side. So how will the inverse look like? The inverse would look like this. So the inverse will look like this. Right, there will be your inverse. So what is the equation of the inverse? Y is equal to negative root x. So you have restricted the domain. This is the restriction on the domain of the original, so that the inverse is a function, because it's one side. If I do a vertical test, it only passes away at this point. For the inverse of this passes there. Fine, okay. All right. Someone is saying, will the question say we must restrict the inverse? No, it will not say you should think that for the inverse to be a function, you have to restrict the domain of the original. They can ask like that. For the inverse to be a function, not restricting the inverse, no. You are restricting the domain of the original. so that the inverse is a function. So that the inverse is, the purpose is for the inverse to be a function. You can have an inverse, but if it's not a function, then that's the issue. Okay. Okay. Let's go back because we're left with okay, right, trigonometry. Okay, trigonometry. Okay, right. Let's look at right, trigonometry, 2016 Gauteng prelim. It's on page 9. Page 9. Right, let's look at this. Page 9. Are we able to do this quickly? Page 9. Right, someone is saying, is it possible that the inverse is beyond the third quadrant? Yes, if the original, also, if you check page 48 on the small book, page 48 on the small book, someone is saying, is it possible that the inverse is beyond the third quadrant? Right, there is a question, 2010 November, small book, page 48, where the original was on the fourth quadrant. The inverse will also be on the fourth quadrant. Sorry, the original was on the third quadrant. The inverse will also be on the third quadrant. So you can check that, page 48, small book, 2010 November. Okay. Right, let's do this. Let's do this question. Quickly. Remember, these questions, they're very sensitive towards where you draw the diagram. First, obviously, make tan subject. Then you draw the diagram in the correct quadrant. Okay. We're supposed to be done, right? We're supposed to be done. We're supposed to be done. Okay. All right. So it says, okay, we're supposed to be done. Let's pay attention. But please make sure you follow through clearly. Okay. All right. Okay. Right. We are given 5. We're given 5 tan theta plus 2 root 6 is equal to 0. The condition is 0 is, the condition is very important. 0 less than or equal to theta less than or equal to 270 less than or equal to theta less than or equal to 270. Okay. Now let's discuss which quadrants are here. That's the most important thing. That's where students start missing it. Which quadrants lie between 0 and 270? But let me draw my Cartesian. Okay, my Cartesian is not coming out good. My Cartesian, okay. There is my Cartesian. 90, 0, 360, 270, 180. Okay. All right. Now, first things first. The first thing is to make tan subject. I'm coming to this part. Let me make tan subject. That means separate the trig function. If I'm separating the trig function, what am I doing? I'll say transpose this to the right. So I'll have 5 tan theta is equal to negative 2 root 6. Then what is tan theta? Tan theta is divided by 5. Tan theta is equal to negative 2 root 6 all over 5. Negative 2 root 6 all over 5. Negative 2 root 6 all over 5. Okay? So that means my tan is negative. Right. Let me come to these quadrants, and I want to throw away those quadrants that are not within my restriction, my part there. So 0 is less than or equal to theta, less than or equal to 270. Which quadrants am I talking about? From 0, let's go together. Let's go together. From 0, remember, trigonometry anti-clockwise. From 0, I'm going 90, 180, then I go to 270. Which quadrants am I talking about? 1, 2, and 3. That means 4 is out. 4 is out. Already you've thrown away 4. 0 to 270, 1, 2, 3. 4 is out. Okay? If 4 is out, right, let me remove this. 4 is out. Right. Then let me look for, check this out here. Tan theta is negative. Negative. Remember, the sign here tells us is the one that directs us to the quadrant. Directs us to the quadrant. Directs us to the quadrant. That's the purpose. The sign directs us to the quadrant. So where do you find tan negative? Between 1, 2, and 3. I know it's positive here. I know it's positive there. That means I'm left with this quadrant, second quadrant. That's where I'm drawing my diagram. Second quadrant. That's where I'm drawing my diagram. So that's how we identify where you're drawing. That's where I'm drawing my diagram. Okay. I first said this is outside my restriction. Then I said tan is negative, but I know tan is positive for the first and the third. That means I remove the first and the third. I'm left with only one, the second, where tan is negative. That's where I'm drawing my diagram. That's my right angle triangle. Right, okay? If that's my right angle triangle, where do I place what? Tan is what? Tan is y over x, opposite over adjacent. Right, okay? Theta there, opposite. This is opposite. This is adjacent. Opposite 2 root 6, adjacent minus 5. Take note, this is where people get confused as well. Even if this is saying negative 2 root 6 over 5, remember, you can write it like this as well. You can say tan theta is equal to negative at the center, 2 root 6 over 5. Or you can write it as equal to 2 root 6 over negative 5, whichever way. This, that, or that, they all mean the same thing. Well, now you need to be careful by knowing where do I find the negative side and the positive side for x and for y. Right, this is 0. I know this side x is negative. I know this side y is positive. Right, then Pythagoras, to get that part, we need to do Pythagoras there. Right, so to do Pythagoras, to get the last part there, okay? Right, so doing Pythagoras for the last part, okay? Let me just do this. Right, doing Pythagoras, okay? Remember, you cannot answer questions before completing the diagram. Questions are answered after completing the diagram. But there's a question, say tan is not positive on the second quadrant. Yes, it's not positive on the second quadrant. It's negative because this is negative. We're not looking for where tan is positive. We're looking for where tan is negative. There, this sign. We're looking for where tan is negative. So someone was saying, say tan is not positive on the second. I'm saying, yes, it's not positive. It's negative because this is negative. Right? Okay. Right. Pythagoras. R squared is equal to x squared plus y squared. Okay. R squared is equal to negative 5 squared plus 2 root 6 squared. So R squared is equal to 49. R is equal to positive 7. It's not plus or minus because we know here the hypotenuse is positive. Now that my diagram is complete, I can start answering questions. My diagram is complete. I'm starting to answer questions. Right, I'm starting to answer questions. First question, sine theta. Sine is opposite of hypotenuse, opposite hypotenuse. 2 root 6 over 7. Cos theta. Right, remember this is without the use of a calculator. Cos theta, adjacent over hypotenuse, minus 5 over 7. Minus 5 over 7, okay? We're done with that part. Okay, so opposite of hypotenuse, sine, adjacent over hypotenuse, that's your cos. Then the next question says 14 cos theta plus 7 root 6 sine theta all over cos of negative 240 times tan 225. Okay, remember, we know the values of cos now, cos theta and sine theta. We substitute them there. So it's 14. What is cos theta? Cos theta is negative 5 over 7 plus 7 root 6. What is sine theta? Sine theta is 2 root 6 over 7. Okay. All over, right? Cos of negative 240, right? Cos of negative 240, these are negative angles. For cos, the negative changes to positive. So this is cos 240. But 240 is which quadrant? Remember, the number should tell you, should drive you to the quadrant. Then you check whether the function is positive or negative. But 240 is third quadrant. How do you represent the third quadrant? It's cos of 180 plus 60. But I know cos is negative on the third. This is negative cos 60. Negative cos 60. So this is negative cos 60. Now, the common mistake with students, guys, I'm really, really crying about this. Forgetting that cos, the negative angle changes to positive. That one, guys, let's be careful. Very, very careful with that. Okay? Then times, what is tan 225? Same thing, tan 225. 225, third quadrant. How do you represent the third quadrant? 180 plus 45. Please, third quadrant or fourth quadrant, never use 270. Never use 270. It's old syllabus. So it's tan 180 plus 45, but tan is positive on the third. So it becomes tan 45. Right, so this is tan 45. Right, remember these questions are without the use of a calculator. So if you just jump and use the calculator there and go to the answer, they will see that you use the calculator. They penalize you. Show that you understand the simplification. This is 14. This is 7. 7 is the denominator. 7 into 14 is 2. 2 times minus 5 minus 10. Plus, this 7 is the numerator, this one the denominator, they will cancel. So 7 there, cancel. Root 6 times root 6, it's 6. 6 times 2, 12. So you can actually do this without the calculator. 12 over, what is cos 60? Cos 60 is like sin 30, co-function. If you know sin 30 is half, then you know cos 60 is also half. So this is minus half times tan 45. Tan 45 is 1. Okay, we go further. Minus 10 plus 2. Sorry, minus 10 plus 12 is 2 over minus half times 1 is minus half. Then tip and times. Tip and times means what? Tip and times means you will say, remember, if you're dividing by fraction, tip and times. Dividing by fraction, tip and times. So this is like 2 times the denominator. You flip around the denominator. The denominator is a fraction. So it's minus half. It becomes minus 2 over 1 because it was minus 1 over 2, minus 2 over 1. Right. So this becomes minus 4. Your answer is minus 4. Your answer is minus 4. Okay. Right. Uh, 5 tan 2 theta. 5 tan 2 theta. Right. So if it's 5, someone is saying, if the question says 5 tan 2 theta, if it's tan 2 theta, then that means you have to draw a diagram for 2 theta. They will tell you that where 2 theta lies between 0 and 270, 2 theta. So if they give you 2 theta, like there's a question actually here which talks about 2 theta or cos. I think it's for cos. Let me check the question. There's a question that speaks about what someone is asking here. Yes, there's a question. Yeah, yes, there's a question for 2016 Gauteng. It's on page 10 on this handout that I gave you. It says if tan 2 theta is equal to minus 24 over 7 and 2 theta lies. So you're drawing a diagram for 2 theta. You're drawing a diagram for 2 theta. Right, okay. All right. I would want us as well to look at, right, quickly. Question. Right, let's look at this. I think this I can write it there. Just do this. Okay. Okay, we are here. All right, I want us to look at that question there, this question. All right, so on page 8. So on page 8, this is a 2015 Western Cape. So on page 8, on this handout, 2015 Western Cape. Page 8, 2015 Western Cape. Okay, I think I can answer this one here. 2015 Western Cape, page 8. All right. So what is this question saying? It's saying if sine 27 is equal to k, if sine 27 is equal to k, if sine 27 is equal to k, right, this one, sine 27 is equal to k, okay? Find cos 63. Find cos 63. There are 2 ways to do this. But first, you can draw the first method is to draw the right angle triangle. My drawing is not that good. Okay, right angle triangle. Right angle triangle, draw it either way. There's my right angle triangle. Remember, sine 27 is equal to k. This k is over 1, and sine is opposite of hypotenuse. So if this is 27 here, opposite k, hypotenuse 1. If you do Pythagoras, this gives you root of 1 minus k squared. Root of 1 minus k squared. 63 plus 27 is 90. That means this is 63, the angle here. So if I'm asked to find cos 63, cos 63 is adjacent because now if I'm looking at it from this angle, that means k is now below the angle. It's adjacent over hypotenuse. So this will be equal to k over 1. So I drew the right angle triangle. This is 90. If 27 is here, sine 27 is opposite over hypotenuse. Then that means if 63 is here, cos 63 is adjacent over hypotenuse, which is k over 1. But also, you could have done it this way. If sine 27 is equal to k, what is 27 plus 63? 27 plus 63 is equal to 90. What should click into your head is what? Cofunction. Cofunction. What should click in your head is cofunction. Right. If it's cofunction, that means that sine 27 is equal to cos 63. That's why if this is k, this is also k. That's what we got here, k. It's also k. Because cofunction sine 27 is equal to 63. Remember, if 27 plus 63 is 90, that means cos sine 27 is equal to cos 63, cofunction. Okay? Right. Then we go further and say, so these are the second method. Cofunction is the second method. First method is a diagram. Cofunction is second method. Okay? Right. Then tan 153. This is second quadrant. So it will be tan 180 minus which angle? Minus 27. Right. So this gives you what? This gives you second quadrant. This gives you negative tan 27. Negative tan 27. But I can pull out tan 27 from the diagram because I drew a diagram for 27 degrees, right? So tan 27 is opposite over adjacent. Remember, it's y over x, so it's minus k over root of 1 minus k squared. Minus k over root of 1 minus k squared, right? Okay. Or if you didn't notice it from the diagram, this part here you could have said, if you didn't notice from the diagram, you could have said, this is negative sine 27 over cos 27. Cos 27 from the diagram, you get cos 27 from the diagram. So this is k over cos 27 is adjacent over hypotenuse root of. So this is negative. So it's negative over root of 1 minus k squared. Okay. Right. Okay. All right. I'm going to answer that one. I have someone was raising a hand here. Okay. Okay. Someone has raised a hand. Okay. Chabalala.
Morning, sir.
How are you?
I'm good, and you?
Good.
So I want to ask on 5.2.1, why is your cos 63 equals to k over 1? Because your adjacent is square root 1 minus k squared.
No, you're looking, remember, we are saying cos 63. There is, you see, the angle is here. If the angle is here, which one is the side? Is the adjacent side? This is not the adjacent side. It's the opposite of 63. The adjacent is this one. You look at it differently. You're looking at it from this side.
Okay.
You understand?
Okay, yes, sir.
Yeah, so the angle below, sorry, the side below the angle is K, below 63. I'm not talking about below 27. I'm talking about 63.
Okay, thank you.
Yes, okay. Right, then there's someone who's asked a question here. Yes, the recorded session, you get the recorded session. Right, so someone asked a question on, there's a question on page, the last page, page 10. Right, last page, page 10, okay. Okay, let's do this. All right, page 10. There's page 10 there. There's a question. Right, so if you have a scenario like this, right, here you have to be clever, okay? Right, if you have a scenario like this, they asked you about tan 2 theta. They ask you about 2 theta. Where 2 theta, that means you are drawing a diagram for 2 theta. It's a simple diagram that is right angle triangle for 2 theta. Right? This is negative, and they're saying between 0 and 180. Right? So if I were to draw it like this here, between 0 and 180, that means between 0 and 180, this is 90, 180, 0, 360, and 270. Between 0 and 180, that means this is out. This is out. Between 0 and 180 is between 1 and 2. But where tan is negative, that means it's the second. Where tan is negative, that means it's the second. Okay. If it's the second quadrant, then I start placing my. Remember, this is for 2 theta. It's for 2 theta. So this is for 2 theta. It's a diagram for 2 theta. Okay. All right. Then, where do we place what? Okay, it's minus 24 over 7. So that means this one is 24. This is minus 7. Right. Pythagoras. You do Pythagoras there. You do Pythagoras, notice that you get 25 there for Pythagoras. Okay. Then if the question says cos 2 theta, right, if it's a question says cos 2 theta, okay, now you don't consider this 2 theta as an identity because the diagram is for 2 theta. So you don't consider this as a double angle because the diagram is for cos 2 theta. You take this as maybe A, cos A, that 2 theta, because the diagram is for 2 theta. Only if the diagram is for theta, that's when you consider this 2 theta as a double angle. Only if the diagram is for theta, that's why you consider this 2 theta as a double. But if the diagram is for 2 theta, you consider this 2 theta as just like cos A. So cos is adjacent over hypotenuse, so it will be minus 7 over 25. Okay? But look at this one now. Look at this one, okay? Okay? We have run out of time, but let's just finish up. So look at this one, it's saying cos theta. This is cos theta. Now you have to think, okay, how can I pull out cos theta here? How can I pull out cos theta? The only identity that I can use, which can give me cos theta straight, is the one for cos 2. What is cos 2? I consider now this is an identity. Cos 2 theta, which one is cos only? It's called it's equal to 2 cos squared theta minus 1. But I know the value of cos 2 theta. There is my value of cos 2 theta. So I'll say minus 7 over 25 is equal to 2 cos squared theta minus 1. You notice where I'm going? This is where I'm going to pull out my cos. I make cos theta subject. If I make cos theta subject, I have to transpose this, divide by 2. I transpose and divide by 2. Okay. Transpose and divide by 2. So you will notice that if I transpose and divide by 2, I will have my cos squared theta being equal to 9 over 25. So if you transpose and divide by 2, you notice that your cos squared theta will be 9 over 25. If cos squared theta is 9 over 25, what is cos theta? Cos theta will be the root of 9 over 25. Then your cos theta will be 3 over 5. So that's how you do the one for cos theta. Right. So be careful. It's there also on the small book. There's a question like that on the small book. On small book, page 74. Small book, page 74, question 4. Small book, page 74, question 4 on exercise 5. On exercise 5, small book, page 74, question 4, where you're given sine 2 theta and you're asked to draw a diagram for 2 theta, but they ask you sine 2a. You're asked to draw a diagram for 2a, but they ask you about sine a instead. Okay, so we have to look out for that. Right, I'm going to send the memo to the groups. You have to go through this, guys. You have to go through this. Right. Are there any questions? I'm going to send the recording. I'm going to send the memo as well. the recording and the memo. Okay. All right. I think we can close the session. I think it was a very productive session. Okay, I have the people asking here. Okay, sine 2 theta. Sine 2 theta. If you sine 2 theta, you do the same. You pull it from the diagram. If you sine 2 theta, you do it the same. You don't consider 2 theta as a double angle. You pull it from the diagram as well. Okay. Okay. Let's see. All right. Okay. If we do all the small questions relating to, okay. So someone saying if we do all the questions in the small book relating to topics of test, yeah, you'll be equipped. Small book. And also, guys, make use of this textbook. What's the name? Make use of Kevin Smith. It's a very good textbook. Make use of Kevin Smith, guys. It's a very good textbook, Kevin Smith. Make use of it, please. All right. I think we are set. The assessment is on Tuesday. So Monday we're attending normally. Then assessment on Tuesday. All the best. But please practice, guys. Please practice. Please. Okay? Take care.